Let's look at another example of using stratification for the detection of effect modification versus confounding. So in this example, we are going to look at the relationship between smoking and myocardial infarction, basically having a heart attack. So in this study, it's a case control study, so I would need to calculate an odds ratio. If I go out and collect the data for this study, this is what I found. You can see that my exposure here is on the left side of that table, and my outcome, MI, is up at the top. And I've set up my 2x2 table, and based on that, I am going to calculate my odds ratio. I calculate my odds ratio, and I get 2.2, and in this example, I have given you the 95% confidence interval. Now, based on this result, I would conclude that there is in fact an association. I see that my results are statistically significant. My 95% confidence interval does not include 1. And to describe the relationship, it looks like there is a positive relationship between smoking and MI, given that my odds ratio is 2.2. I might want to investigate this relationship further and think about, is there a potential variable that plays a role in this observed relationship? Something I might want to look at is dietary fat consumption. I know that based on the literature and my knowledge in this area, I know that dietary fat consumption could somehow play a relationship play a role in this relationship between smoking and myocardial infarction. So what I would do is I would set up my analysis according to the levels of the strata of that third variable. In this case, what I would do is analyze my data according to those with low dietary fat consumption. That's going to be stratum 1 at the top. And then I'm going to calculate those with high dietary fat consumption. That's going to be strata 2, shown by that table at the bottom. I'm going to set up my 2x2 table with my exposure and my outcome variable. And I'm going to calculate my odds ratio in 95% confidence interval. I've given you the answers to these. They're over here. And interestingly, what I have found was that there does not appear to be a relationship between smoking and MI among those who have low dietary fat consumption. My results are not statistically significant, so I would conclude that there's no association, and I also see that my odds ratio is 1. So I would conclude that there's no association between smoking and MI in those who consume low amounts of dietary fat. However, I see that there is definitely an association in strata 2, those who consume high amounts of dietary fat. If I look at the results here displayed on this right side of the screen, I can see that there is an association because my results are statistically significant. So I would say there is an association among those who consume high amounts of dietary fat, and I would describe that relationship as positive. I can see that it's 6.29 is my odds ratio. So is there effect modification? Absolutely. I see that those odds ratios are very different from one another. And I know that I do not have confounding because these strata-specific measures, these odds ratios, are not similar at all. So I would conclude that I have effect modification because these strata-specific measures are very different from one another, and you can see that the crude falls just in between them as well. I do not have confounding because these strata-specific odds ratios are very, very different from one another, indicating that there is no presence of confounding according to this variable. So in terms of what I want to report for my overall takeaway results, I know that dietary fat is an effect modifier. So I need to report the strata-specific measures separately, my strata-specific results. So I would report the results for strata 1 and I would report the results for strata 2. I would not report any kind of adjusted results, and that's because that adjusted measure, if I calculated an adjusted measure, it would mask this effect modification that I have, so I need to report these separately.